Every query you write has to run somewhere. Every dashboard load, every DBT model, every notebook cell, all of it hits a compute cluster before it touches your data. Today, we are going to walk through what compute actually is on IOMETE, what is happening under the hood when you run a query, and how to size it for different kind of jobs. Let's start with the simplest possible definition. A compute cluster on IOMETE is a fully managed Apache Spark cluster running on Kubernetes, exposed to your tools through multiple protocols. Three things make it different from a traditional warehouse. Let's explore them.
First, stateless. The cluster does not store your data. Data lives in object storage like S3. Metadata lives in the Iceberg catalog. When the cluster shuts down, nothing is lost because nothing was ever stored there. The cluster is just a processing engine. Second, isolated. Each cluster has its own driver, its own executors, its own configuration, and its own network boundary. Two clusters running at the same time cannot interfere with each other. A heavy batch job on one cluster has zero impact on a dashboard query running on another. Third, multi-protocol. The same cluster serves the SQL editor, BI tools like Tableau and Power BI, notebooks, DBT, Python, and Spark Connect, all simultaneously. You do not need a separate connection or a separate cluster per tool. One cluster, every interface. At the top, you have your clients. The SQL editor, BI tools, notebooks, DBT, Python scripts, all of them connect through standard protocols, JDBC, Spark Connect, or Aeroflight. Those connections all land on the compute cluster. Inside the cluster, there is one driver pod. That is the coordinator. It receives your query, parses the SQL, builds an execution plan, and distributes the work. Below the driver are the executor pods. These are the workers. They read the actual data from object storage, process it in parallel, and send results back to the driver, which assembles the final answer. At the bottom is the storage layer. Packet files, Iceberg metadata, permissions. This layer is completely separate from the cluster. Notice that gap between the compute layer and the storage layer. That separation is the whole point. The cluster can scale up or down, restart, or be replaced entirely without touching the data. The data has no idea what the cluster is doing. They are independent. This is what decoupled compute and storage actually means in practice. Not a marketing phrase, a physical separation between where processing happens and where data lives.